So in these problems, we are going to look at solving a right triangle. So when the instructions say solve the right triangle, what they mean is they want you to find all of the missing sides and angles. So for example, the first one here, so maybe my right triangle looks like this. So here's my right triangle. We'll call this side A. This over here is angle A. So usually we use capital letters for angles and lowercase letters for sides. This angle here, 42 degrees. This side here, little b. And this side here is 22. So one of the things first off to remember is that all of the angles in a triangle add up to 180 degrees. So it's actually pretty easy for us to find angle A by saying that angle A plus the 42 degrees plus the 90 degree angle would have to end up being 180 degrees. So if I add them together, A plus 132 degrees is equal to 180 degrees. And if I take the 132 away from both sides, A is going to end up being 48 degrees. So this angle here is 48 degrees. And then now we can pick on what side we want to find. So if I tried to find little a first, there's lots of ways you could do it. So if I'm going to find little a, if I look here at 42, I know that the cosine of 42 would be the adjacent side, little a, over the hypotenuse 22. So the cosine of 42 degrees is going to be little a over 22. When at all possible, I try to use the values that the original problem gave me. So that's why I wrote that 48 degrees in pink. In this case, you could use the 48 degrees because we didn't round, but if you're ever rounding, you want to try, if at all possible, not to use those rounded values again. So in this case, if I try to solve for A, I'm going to multiply both up by 22. So 22 cosine of 42 degrees is equal to A. And so if I work that out, A is going to be approximately 16.3 if I punch that in my calculator and round. If we look at B, and again, if we try to use that original angle of 42 degrees, so 42 degrees, B is opposite the 42 degrees, and then again, the hypotenuse is still 22. So the sine of 42 degrees is equal to the opposite, B, over 22. So again, if I multiply the 22 up, so 22 sine 42 degrees equals B, and B is going to end up being approximately equal to 14.7. So now I found all those missing sides, right? I know that A is approximately 16.3 and B is approximately 14.7. So I have everything that was missing. So let's try another one. So B, so let's say that this angle here was 41 degrees. This side is 26. Here's my right angle. So this is C, this is A, and here's capital B. So again, we're just trying to find all those missing pieces. So I need to find little a, little c, capital B. Again, capital B is the easy one because all the angles in my triangle add up to 180 degrees. So capital B plus 41 degrees plus 90 degrees has to be 180 degrees. So capital B plus 131 degrees has to be 180 degrees. And then I can take the 131 degrees and subtract it from both sides. So B is going to end up being 49 degrees. And so this B is 49 degrees. And again, remember, I want to try to use the information that was originally given to me. So 41 degrees, the side adjacent to the 41 degrees is 26. So if I'm looking for A, I'm looking at the opposite side. So the trig function that relates opposite and adjacent is tangent. So the tangent of 41 degrees would be the opposite A over the adjacent 26. And so if I solve for A, we have 26 tangent 41 degrees equals A. And if I just plug that into my calculator, we get that A is approximately 22.6. We can do a similar thing to try to find C, but again, we're going to try to use C, 41, and 26, the original things given to me. So we have the adjacent and the hypotenuse, so we're going to use the cosine. So the cosine of 41 degrees is equal to the adjacent, 26, over the hypotenuse, C. So if I multiply the C up, we end up with C times the cosine of 41 degrees equals 26. Divide both sides by the cosine of 41 degrees. So C is going to be 26 divided by the cosine of 41 degrees. And so that's going to round to be 34.5 degrees. So that's what we're looking at there. Or not 34.5, not 34.5 degrees. Because it's just a side. So now we've found all those missing pieces in that triangle, so we have solved that triangle.